Hey, good morning, Eric. I'm going to be back in about 5 minutes. I've got to bring my kid down the hall to a summer camp. We're both at school. So if I'm a little late, I'll see you in just a few minutes.
Okay. Yeah. Good morning, Beverly. How's it going?
Good morning. Guess what I tried to do yesterday?
Was it code?
That, yes, and more. Oh my goodness. Yesterday I finally had someone set up my desktop and we tried to hook the robot to it. Here's the desktop. And it would not sync. It would not work. So I am mad at Best Buy. And I'm trying to even log into Zoom and see if it even works with this class. We were able to type the code in there, but had to transfer everything from email over to this. But as far as trying to plug it into the robot here, it definitely wouldn't work. So, and then I can't even get sound on it. So that's the school laptop once again. I guess I'll be working on, I don't know what to do. Maybe I'll probably have to still work it on there because that's going to plug into the robot to, feed it the info, stay on the tablet and talk But I was hoping to, I was hoping to be able to type with y'all today if there was anything to type and even talk through this, because I
So,
even have a
yeah,
camera
that's
hooked
good.
up to it. I'm sorry.
Oh, no, it's fine. So that, so your desktop, is it on the internet right now and everything, or?
Yeah, because I recently got Wi-Fi hooked up. I think it was last Wednesday here at the house.
And you can like go into like Vex code just in the browser.
I
Like
can go on. Yeah, I can go on the Vex. Let's see right here. Let me move this out the way.
and you
I
also
can
can't
do that.
can you, and you can't connect to the Zoom either?
That's what I'm trying to do right now.
Okay.
So
Because even if you don't have the app installed, you should be able to do it through a browser window.
I'm gonna see. I'm trying to. It's asking me about testing speakers and stuff. I just need to get out of there.
Okay.
I don't need the whole sign in. It's still streaming though. Video.
Do you have a webcam on that desktop, or?
It didn't come with it. I ended up, I keep dropping my mouse. I have this little device. It's a Pivo camera.
Okay.
Yeah, so I'll have to open that up in the meantime. Let's see. But it's not even let me not seeing any video.
Oh, good morning, DJ and Leah, by the way. So it's, I can't really read your screen very well, but you can't connect to the meeting right now, or?
I'm still trying. I'll just stay on here, of course, and play with it. And if it works, I know you'll hear a ding come in.
Does that say leave meeting? No.
Yeah, it says leave meeting, but
Well, maybe leave and try to get back in again, because you're not on there right now. Why don't you just go? Can you just on your desktop? Can you just go to that link? The link in the spreadsheet, instead of going that way and click enjoy meeting and all that. Just follow the link in the spreadsheet so you can hit cancel or whatever.
because what I did, I went through Vanessa's page to get the Zoom on her email. Wait, let me see if I can find you again.
Sure. Here, there's someone knocking. I'll be right back. Give me 1 second.
Okay. All right, let's see.
So I guess you can continue sorting, right? Yeah. You can sort all the black stuff. So that's by their different types of pieces. You probably just need a bunch of different containers to sort them.
Well, I was gonna say, should I just like empty one of these and just put them?
Yeah, you could. I don't know if it's gonna be big enough.
Yeah, that's true.
Here's the you can use the bigger boxes.
There's some of these.
Yeah, you can use that.
All right.
So
I checked in at Sonic at like 7:45, and I didn't get my food until like 7:54.
those terrible people.
Terrible.
Yeah. You could also, if that helps, like for instance, I was swimming expensive earlier. And we have these crawfish trays. So you could just kind of dump everything into the tray and then kind of sort through it that way.
Gotcha. But yeah, I was always wondering whether I could like put these black things in different boxes.
Yeah, they're different parts. So
All right. Give me the cross.
I don't know where you're gonna sit.
I'm gonna figure that out. If the field was on the ground, I would sit down in the middle.
That's the last thing I want.
Yeah. Sorry, I'm not getting on that.
Did you find the do you want me to just share you the through your email?
Yeah, that'd be perfect. Yes, thank you.
Okay. All right, so I emailed you the link to the Zoom.
Okay.
So did Brian come back? Yes. Okay, good. So okay, so you were able to drop your kid off, but what kind of camp is he doing?
It's like Lego, some kind of Lego summer camp that the elementary teachers at our school puts on.
Is it like a Lego robotics thing? Like
Oh no, he's 6, so they're.
Oh.
I mean, I guess they could start, but I don't think he's ready.
All right. And who was that? Oh, sorry, I'm just trying to get everything in position. So I was looking, okay, so we have our final project coming up. I think I'm gonna swap Monday and Tuesday's lessons around though. In case you wanted to use, how many of you actually have a vision sensor that you can play around with already? So like Leah has one and Logan has one. So in case you wanted to incorporate it into your final project, we'll go ahead and look at how to use it today. So we're almost done, right? So we've got today, tomorrow, and Wednesday. And so what we're gonna do today is we're gonna work with, I'll show you how to use the vision sensor. And I'll also, we'll also look at some code of how, like, for instance, you can combine 2 sensors together to do some object tracking to follow something around, like what we did for our senior project this year. Additionally, and so, and then the rest of the time, you guys are going to be like working on your final project. Oh, so I see Beverly's got Zoom going at least.
Yeah.
So that's a good sign. So at least you'll be able to do like a screen sharing or stuff like that. So
Yeah.
if you needed to. Also, so can you go to the code V5 link? I mean, even if you don't have the app installed, Beverly, on your desktop, you could probably still go to it if you wanted to.
Okay. You're talking about this, right?
Yep. Yep. Okay, so I guess you're in good shape then, because you can type code on there and
Yeah.
except for you said it won't download.
It won't download to the robot, and then I do not have sound. As you can see, it says it's there, but we've been trying to figure out where to pull it up at, and nothing has come through. So
And you just, is that a brand new computer?
a brand new one, yes.
Hmm.
I had it sitting up in the house, cool climate, everything. I just had, finally got Wi-Fi in the house and moved back in and got it hooked up, and this is what's happening.
I see.
Yeah.
Okay, so that is a shame.
Yeah.
Okay, anyways, let's go over our word for today is going to be vision, because we're going to be using the vision sensor today. So our word will be vision. Now, some of you don't have this sensor, and some of you do. So I might have mentioned before, but you can't actually calibrate the vision sensor if you're going through the browser. You have to actually go through the app. So that's why you see me hooked on right now with two things. So I've got my Chromebook up here because it has the app on it. And so I'm going to kind of show you through that Chromebook how to like calibrate the vision sensor and that kind of stuff. But before we get into that, let's talk about our code from last week. So like last week, we were trying to do a Roomba. How many of you guys got your Roomba to work? Okay, Brian and Logan got their Roomba to work. Did you run into anything unexpected or anything with the Roomba? Or were there any like additional things you had to do that you didn't realize you had to do, or?
But I did mine in front of everyone, so not really.
Okay. So it all worked okay. So it wasn't like yeah.
I mean, the only thing I have with issues is like my wheels aren't perfect, so it just kind of wobbles a little bit. But other than that, it's good.
That's good. Okay.
Mine, I mean, we think we set it to only do right turns.
Well,
Like it could do a.
Well, I think with what we figured out, although it was a right turn, it should have been like a negative right turn would do a left turn, right? Because like I think if I remember correctly, you figured out the values to do between like a negative 90 to a 90-degree turn, right?
Yeah, we changed it from what was in the instructions.
Yeah, because the
Okay.
instructions was only doing right turns, and it was doing like really, really big turns too, like over 360-degree turns. But I think we ended up yeah, because I seem to remember us doing the calculations to figure out for a 90-degree turn. And so we went between like a negative 90 and a 90. So that would do both left and rights. At least it should have. Were you not experiencing that at all?
I didn't like run it for a long time, and it might have just been a function of the number of times it hit the wall. It was like it would adjust and then hit and then adjust a little more or adjust back, and so it wasn't doing as much. But I didn't just let it sit there and run over and over again. I just kind of like plugged it, let it do its thing. Okay, it's working, and then stop.
Because I think it was Brian that was doing the code last time, and I seem to remember like you pressing a button a bunch of times until we finally got like some negative numbers.
Yeah,
or was
gave
it
me
all?
like 5
was all-
positive numbers in a row or something before it would
Yeah.
give you, but it finally did.
But going a negative right turn is the same as going a left turn. So so that should have worked out like so. Okay, so today we're going to be looking at the vision sensor. So let me show off this robot here. I got so much stuff on my desk right now. Let me. Oh, I didn't mean to turn off the camera. So I'm gonna turn on my document camera. Just so you can see the setup I have here. It's taking a while to do. I don't know. Maybe I can just show it here. Okay. So so this is that same Gearbot that we have. It's just on the back here. I added a little a C channel just to the back to give me some of the mount stuff too. And I mounted the vision sensor as the sensor on top. And then I also mounted a distance sensor as well. Because like I said, we can look at like maybe object tracking using both of them. And that's really all I did here. So that's why it's set up right now. So I'm going to be coding. I'm going to kind of be doing this part today, if that's okay with you guys. But I'm going to be kind of coding on this Chromebook over here. So let me share the screen on this one. Oh, let's see. I want the entire screen. Is it showing up? Okay. Oh, okay. So I actually have VEX Code pulled up in the app right now. So you can kind of see, so I'm just going to start a new program. I'm going to go to File and New Text Project. And we'll just start a brand new project. And what we're going to do is we're going to just, I'm going to show off how to set up the vision sensor and how to calibrate it and all that kind of stuff. So, anytime we make a program, we're going to add some devices. So I'm going to go ahead and just add a left motor and a right motor like we have been. Is it the right motor we've been reversing or the left motor? I don't remember.
Left motor.
It's the left motor. Okay. Of course, yeah. And if it's driving backwards, we'll know we got it wrong, right? Okay, so we have a left motor, a right motor. Let me see what port I have this plugged into. And let me make sure the port works. Looks like I've got it in port 5. Oh no. Vision sensors in port 8. Okay, so I have a vision sensor in port 8. So I'm going to pick vision sensor, pick port 8, and you can pick whatever port you have it in. I guess I'm fine with like calling it vision 8. And then I also have a distance sensor, not a rangefinder, but a distance sensor. So the laser one, and it's in port 10. So that's my setup on this robot right now. I do have a inertial sensor plugged in port 3, but I don't think we're going to use it. But I guess I could put it in there. Well, no, I won't. It doesn't need to know it's there. Okay, so let's talk about first off calibrating the vision sensor. So as I mentioned before, you have to let me pull up the vision sensor. So you see this configure button here. This configure button doesn't work if you're trying to do it in the browser. If you're in the browser, that's why you have to use the app. But to configure the vision sensor, you actually have to plug in directly into the vision sensor. So instead of plugging your cord into the brain, there is also a USB port on the vision sensor. And so that's what you have to plug into. So let me do that right now. And then you can hit configure. So once again, you have to plug in directly to the vision sensor because the vision sensor, as I mentioned the other day, it is just a Pixie camera and a VEX case. So it has its own onboard stuff. So you can see right now it's seeing everything. So it's showing you what you can see in the camera here. And so the way this Pixie works is it has different color signatures you can kind of set. Oh, and I think my cable came loose there when I was moving it. Okay, there we're back. The light from outside window might be, that's going to throw it off a bit. So let me adjust these blinds. I don't think that helped at all. Yeah, that's a little better. Okay, so like for instance, so I have one of these discs from last year's game. And so let's say we want to track this disc. So the way you kind of do that is, so I can hold the disc up here, and then I'm just going to freeze my screen just to so I can work with it a bit. And then what you do is you pick what you want to track. So what I'm doing is I'm just dragging on the screen here, and then I'm going to call this signature maybe disk and set it. Well, maybe I have to try it again. So let me select it again, and we'll set it. And so as you can see now, it's kind of picked up the disk, and it gives us some information here on here too. Like it tells us the center X value, the center Y value, the width of the disk, and the height of the disk. So how tall it is and how wide it is. And then you can also adjust the sensitivity. So if it isn't like picking up the whole disk, then you can crank up the sensitivity a bit. Now, if you crank it up too much, it starts picking up other things and thinking it's also the disk, because really it's only tracking by color. So we're going to set up the sensitivity at least a little bit. Look like 5 is probably good. And that way, even if it's kind of turned at an angle. So let me unfreeze the camera and let's see if it tracks the disc now. So yep, so it's picking it up. And so as you can see, as I'm moving it around, it's still tracking the disc. And you see how it has my center X and center Y values, width and all that. And notice it does call it disk up here too, which is kind of cool. Let me see, do I have anything else I can track? So okay, so additionally, like for instance, I have like this red gear here. Why don't I try? So I'm going to freeze again, and I'm going to select this red gear, and let's set that. I kind of want to set it so that it picks up the gear, but not really anything else. I want to call this one gear. And so let's unfreeze it. So here is the gear. Now it's also kind of, I guess my ears must be really red because it thinks my ears are a gear now too. So here it's picked up gear. Maybe I have it set a little too sensitive because it's kind of picking up some of my skin tone. So here it's tracking both the disc and the gear. And so it will also track, let's say if I have multiple discs, I think it can track up to a dozen objects at a time. So there are some other cool things you can do with it. One cool thing, let me see. Give me 1 second.
Yeah. So, you did,
I just did that
interactive box.
access stress again.
You haven't been, I mean, you.
I guess I should have prepared some of this in advance, sorry. Okay, so I'm back. I'm gonna clear. I'm trying to use a mouse on the wrong thing. So I want to clear this signature. So okay, so here I've got two different colored markings. I'm gonna freeze the screen. And let me, I'm gonna set these up one at a time. And I'm gonna call this one R strip. And let's adjust its sensitivity to kind of pick up a good bit of it. All right, and then I'm gonna select this part, and I'm gonna set that. And I'm gonna call this one like B strip. And set its sensitivity just a little bit. Well, maybe not too much because it's starting to pick up. I'll just move the screen out of the way. Okay, so do you see how it's picking up both R strip and B strip now? Okay, so another kind of cool thing you can do with it is you can put in these codes. So if I want to do, so for instance, I could do R strip, comma, B strip as a code, and I'll call it, I don't know, square or something. And now, when it sees them both together, do you see how, and maybe I need to, do you see how now it's tracking them both together as one object? And also, do you see how it gives you some different, some extra information too? The extra information it gives you now is the angle too. So watch as well, let me go back to my objects and crank up the sensitivity of my blue strip a little bit so it can pick it up a little better. So now it's tracking it as a whole object. I don't know why I didn't keep it as square. It's calling it like signature 23 for whatever it is. But now as I tilt this, see, it's actually changing the angle. So now it's like 85 degrees. And now it's like 180 degrees. And so by combining two strips together, you can actually do like rotational information too, in addition to the X and Y position and everything else. So that gives you some extra capabilities with this. So for instance, if you had like tracking marks on something, you could tell if it's upside down or not or whatever. So like, for instance, like maybe if you had a box that you wanted to make sure it was the right side up, you could have like some color coded strips on it so it knows, or I don't know. I'm sure you could probably think of all kinds of things to do with it. So right now we have these yellow objects with disk and red and blue. It probably is going to pick this up as R strip. Yeah, it is, because it's tracking by color. So just as long as it sees a color red here, it's going to think it's whatever we labeled it. So that's kind of how that goes. And so that's the configuration part of it. So once we have it configured, make sure you hit done, and it's going to kind of save those values in the pragma, if you were to kind of look in here. So you see these lines of code where so it's basically giving the hue information or color information, I think, for each of the signatures. And it's just having that all kind of set up. So we have a Vision 8 disk, a Vision 8 R strip, a Vision 8 B strip, and a Vision 8 square that we all kind of have set up. And then it's also kind of defining everything. So this is part of the auto-generated code when you do all your configuration. But that's usually code that's hidden from you. But now that we have it, now we can kind of work with the sensor now. So any questions about the setup there? Does anyone that has a vision sensor want to just like hook it up and see if they can go through the setup, or do you think it's relatively straightforward, or what? But
I'm looking through my box right now and see if I have one out of all the sensors I found.
okay.
I don't have the program on my computer. I'll just be using the web browser, so I don't know if I can't fine tune it, right?
Yeah, you're not going to be able to fine tune it like that. However, it does have some default colors. Like I think it has like red, green, yellow, blue. So you can actually use those values, but they won't be fine tuned. So they might not pick up like you want them to.
Yeah. I still don't understand why it's not showing up in mine. I have to send it. I'll probably email our tech center and they probably just add it to my software center or something.
Yeah. That's what we had to do on our side. I just sent it to our tech, said we need these apps, and they put them on there. So okay, so next up, let's go into actually programming this thing. So let's program it so that our robot will turn and follow an object. Actually, let me hop back into the vision sensor configuration, just so you can kind of see. Okay, so here's my object here. So basically we have this data that we can work with. We have center X, center Y, width, and height. So that's kind of the information. And even with multiple objects, what it will do, okay, so now it's thinking this is all the same object because we get them close together. But you do have the option of it just grabbing the largest object, because the largest object is probably going to be your closest object. And so you can get the X value for the largest object. You can get it for the other ones too, but most commonly you're just going to get it for the largest object. And that's what we're going to look at. So notice that we probably want to just pay attention to our center X values. So notice that kind of in the center of this thing is we get a center X of about 150. And if I go over to one side, like if I go this way, the center X, since it's such a big object, it's not going to hit 0 because it's going to get the center of that object. And if I go the other way, it goes up to almost 300, right? So that's kind of the range of center X values we have to work with, from 0 to 300, with the middle being 150. And so if we want the robot to track something and follow it, basically what we want to do is make sure that the center X value stays about 150. So what that means is if it's less than 150, we'll have it turn into a one-way until it's 150. And if it's more than 150, we'll have it turn the other way. Now, we can do that with a bunch of if statements. Like we could say if center X is less than 150, go one way, or if it's greater than 150, go the other way. Which I think is how, if you look at like the sample code in the slides, is how it's done. But honestly, that's not the best way to do it, because that's going to give you like a fixed amount of turning no matter what. And so instead, what we're going to do is we're going to actually use proportional control for this, because even though I said earlier we probably wouldn't use it in class. It's just so much more useful in this situation. So what that means is the closer it is to that 150, the less it's going to turn. And the further away it is, the more it's going to turn. So let's actually write some code for that. So to do this code, I'm going to create a variable that I'm going to call turn speed that will kind of keep up with the speed I should be turning at. And so I'm going to make it a float, I guess, and it's going to be called turn speed. One thing, how many of you guys are actually using the using this on a Chromebook or something? Because I have the weirdest thing. Do you see my cursor on the Chromebook by any chance? Because I'm still sharing my screen. It for whatever reason, and this happens with everyone on the Chromebooks, it does not put it in the center, or no, it doesn't put it at the end of the line. Well, it is at the end of the line, but the cursor doesn't show there, so it's really throws me off there. So anyways, I don't know why it's like that, but that's how it. So I'm just going to set. See, because now I don't know where the cursor is. Okay, so I'm going to just set that turn speed equal to 0 to start off with, but we're going to be changing that later. Now, what I'd like to kind of do is also maybe set this up as a function to kind of set up my turn speed. To kind of figure out what my turn speed is, and then I can just call on it later. So let's make a function. And I guess this is actually going to return. Well, it doesn't necessarily have to return a value. So we'll just make it a void. Yep. So it's not, well, it's going to update turn speed, but it's not like the function is going to be feeding back any information. It's just updating turn speed. So it's still going to be a void. And what do we want to call this? Like maybe update turn or set turn. How about set turn? Set turn sounds good. So we're going to make this function called set turn. We're not going to feed anything into it, so it's not going to have any parameters. And then we're going to kind of put our stuff in here. Please, everyone, let me know if I'm going too fast with this so far, or if I'm not explaining this properly as I go through. Like if there's any sort of confusion at all, please stop me at any time. Like,
I did not find a vision sensor.
okay. Yeah, if you have older equipment, because they didn't really start putting the vision sensors until they had the V5 stuff. They came with pretty much all the V5 kits, so I feel it's kind of odd that you don't have one at all. But so if you don't have it, you might not like if you don't have it for your class, then you're probably not going to do this unit at all then, right? Because you don't really have it to work with unless you order some. If I remember correctly, they're like $70 a piece, I think, which is about twice the price of a Pixie. But at any rate, so okay, so let's go through what you have to do to actually use this vision sensor. So if we go into sensing here, and we look here in vision, we have a few things. We have this take snapshot. We have vision largest object, vision object count, and vision objects. So, and there's and then with largest object, you have things like the center X and center Y and that kind of stuff. So, for the vision sensor to work, basically, what you have to do is kind of take a snapshot with what you're trying to track. So, so for instance, if we're so we're going to take a snapshot here. And the signature here is going to be that disk that we're tracking. Oh, hold on. The cursor just isn't in the right spot. So can I just, so that's going to be like vision. So if I start typing vision, so do you see like it kind of helps me fill that in, but I'm going to just be tracking that disk that I set up. So I'm going to pick that Vision 8 disk. So what's that going to do is it's basically going to tell like future lines of code that if I'm looking for like the largest object or something like that, that it's going to be based off of that color signature. So if you're tracking multiple things at the same time, what you have to do is like take a, so you would take like a snapshot, like say if you're trying to track a red and a blue thing at the same time, you would take a snapshot of the red thing and then do your red thing stuff, and then take a snapshot of your blue thing and do your blue thing stuff. If that makes any sense. So right now what we're doing is we're taking a snapshot, and this is basically telling the brain that it's going to be looking for disks, which is basically yellow. So we're basically just looking for yellow here. Now that we've done that, what we kind of want to do now is we want to change that turn speed value. Yeah, so what we'll do is we'll change that turn speed value. So what we can do is we can say turn speed. Well, typing on this Chromebook is weird. So what we're going to do is we're going to grab the largest object that we see. And then we're going to grab the center X of that largest object. So vision's largest object, center X. And so that's going to kind of get that center of that object. And basically we want to set the turn speed to kind of like that minus 150. Let me make sure that compiles. Yeah, let's save this as, we'll call this vision. Vision. Vision already set. Okay, let's call it someone else then. Let's call it camera.
How did you do that again?
Which part? Saving it?
Oh, that was saving it, and it wasn't adding anything to a menu or anything, right?
No, I think, well, when I tried to compile it for the first time, it asked me if I wanted to save the program, and I did want to go ahead and save it. So I just, so you could do the same thing by just hitting file and save, or file and save as. I'm actually going to put this on slot 2 as well, because I have someone else in this robot in slot 1 that I don't want to overwrite. Okay, so you see how it built, and so we didn't have any problems there. Okay, so let's kind of walk our way through this. What's going to happen when we say run this set turn? Okay, so let's say the object is exactly in the center. What is going to be my turn speed in that case? Because exactly in the center, what value should my center X be?
I'm guessing 0.
So the center of the camera is 150, right? So if it's right in the center, I'm going to have 150 minus 150, and that would give me a turn speed of 0. Okay, so what if it was like, say, all the way at like 0? So if it was all the way over on the screen, so it's not going to quite get to 0, but it'll be kind of close to 0. So what would be my turn speed in that case? If the center X was 0.
Negative 150.
Yeah, it'd be like negative 150. And then what if I was all the way on the other side where I was reading 300? What would be the turn speed then?
150.
So those, okay, so since this is going to be in percent, those values are kind of high, right? Because so negative 150 and 150, you can't go over 100% anyway. So so what we might want to do is we might want to set up another variable as kind of like a to kind of like affect how big that effect is. So I'm going to set up one more variable. It can probably just, no, it'll be a float. So I'll make another float. And what I'm going to call this one is KT. So this is going to be a turn constant. So this will affect how big a turn I can make. So how sensitive my turns are going to be. So I really don't want it to turn maybe more than 50%, even at the max value. So what should my KT probably be? If I'm going to use this as a multiplier for a number that I'm going to multiply to this part right here. So remember, my maximum values are like 150 and negative 150, and I really don't want to make it more than 50. So
should be like 0.33 or whatever.
Yeah, so we'll just say 0.3. So that will be my KT will be 0.3. So what that means is I'm gonna whatever this is, I kind of want to multiply it by that 0.3. So what I'm going to do is I'm going to take this, and this is where the cursor is throwing me off so bad. I think that's right. Okay, yeah. So I'm going to put all this in parentheses here. And I'm going to multiply it by KT. Actually, I'm gonna swap this around in KT. So lowercase k, capital T. So if it's in the center, that would be 150 minus 150, that's 0. And 0 times 0.3 is still 0. If it's all the way to like the 300 side, then it's going to be 300 minus 150 is 150 times 0.3, which is about 50, a little less than 50. And if it's all the way on the 0 side, well, 0 minus 150 is going to be negative 150 times 0.3 is going to be about 50. So this will give me a range of values between about 50 and negative 50, right? So maybe we should start commenting things because so I'm going to say this KT this so this variable controls the since this cursor thing is really throwing me off. Now the cursor is like way over, way off. And turn speed, yeah. And let's see here. What can we say about set turn? Mm. Okay, so should I comment more? I think that'd probably be good. Okay, so that's going to give us our turn speed. So when I run this set turn function, it's going to grab that turn speed. So how about in our int main? Let's actually use that turn speed now, or that set turn. So in our main, what we'll do is we're going to make another infinite loop. So we're going to say while true. And while true, what we're going to do is we're going to run this set turn so that we can grab a new turn speed. And then what we're going to do is we're going to do a motor spin. Leah, are we sure we can't use motor spin and use speed in it? Or let me try
Wait,
it.
what?
Okay, remember before you were having problems with motor spin? I'm going to try I want to see if this works. If that compiles. Yeah, that doesn't work. Okay. So actually what we're going to have to do first then is what we're going to do is we're going to set the velocity of the motor. And we're going to set it to turn speed.
You can do spin, and then you have to give it direction, comma, velocity units.
So you can?
I think so.
Well, that's what I just tried.
Oh, you gave it units?
Yeah, the units I said was percent.
Did you forward at the beginning?
Yes.
Oh, I don't know why it didn't work.
Can you do it?
Oh, I'm looking at their reference.
Yeah.
The description of that method says, or function says you can do it, but I don't know.
Okay, I'll try. Let me try one more time and tell me if I'm typing it wrong. But I have a left spin forward, comma, turn speed. So that's going to be my speed, and then comma, percent, because that should be my speed units, right?
Yeah.
Do you see any problems with what I have?
No, I feel like I've written this before and it's worked.
Okay, so, but, oh, I know why.
But you got about the variable.
Yeah, it's my fault. Okay. Let me find
Capital S.
Yeah, that's the problem. So it will work. I thought it would, but when Leah was having trouble with it the other day, I was like, maybe it doesn't work. Okay, so it does work. Okay, so have our left motor turn speed. And let's copy that line. And we'll just change this to right motor. But since we're turning here, we want this one to be reverse, or at least one of them be reverse. Now, if I have that wrong, then what it's going to do is it's not going to follow it properly. Okay, so
I'm sorry. Do we need a false? Because don't we want them to do it at the same time?
well, with spin, it's spin 4 that we need a false for. Spin just turns on the motors at a certain speed. It doesn't tell it to go for a certain amount of time or distance or anything like that. All it's doing is turning on the motors. Okay, so this should hopefully be enough. Now there is, what we're going to find is there's probably going to be some more stuff we want to add. But this is it in its most basic form. So I'm going to download this code to this robot, and we're going to see what it does. So let's, okay, so it did pick it up. Now, what we're probably going to see is it's going to do some behavior we probably don't want it to do. But I'm going to start by holding the object in front of it. Let me clear off some space. And let's run this. Whoa. Okay. Wait. Here, I'm gonna turn off my screen share. Any second now. So let me stop this share quick. That way you can kind of see on. Hold on. Nope. I'm afraid it's going to run away from me, so I'm kind of like holding this object here. So I'm going to change. Well, that's kind of upside down. That's weird. Oh. Can you guys see that it is following along? I know the screen is upside down. Actually, here, let me just turn this. I'll use this here. Are you laughing at me, Leah?
It was just shaking. I was like, I'm gonna throw up watching this thing like shaking. Okay, we're good. Okay.
All right. So you see, I got the disc here. You see, it's following along, and it's keeping up with it, right? So if I just move it a little bit, it moves a little bit. If I move it a lot, it moves a lot. Okay. Now let me ask you this: what's going to happen in it when it doesn't see a disc? Any ideas?
Earlier when you didn't have the disc up, it was just spinning in circles. So I'm guessing that's what it's going to do.
Maybe it actually kind of depends. And what it depends on is where it last lost sight of the disc. So if I yank the disc down, like, well, I guess it does spin in circles. Okay. So
It's searching for the disc, right?
it is well, we never told it to search for a disc. But what it's really going to do, let's see if I can make it turn the other way. No, it's just always going to default to that. I guess if it doesn't see a disc, then it's just grabbing a value of maybe 0, I guess, right?
Yeah, because we told it that. We told it if you don't see anything to use 0, and that.
Yeah, that's right. So, and that's what's happening here. So it's just, if it doesn't see a disc, it's using 0. And that's actually probably fine. You know what? Here, let's follow this thing. So other than the fact, okay, so I'm going to stop this. Stop. So honestly, I kind of think that's pretty cool that, you know, it can track something like that, right? I think the kids will also think that's really cool. That's, which is one reason I like using a vision sensor, because it really captures the interest of the kids for sure. Being able to do something like that. And so I don't think looking at this, I don't think we really need to maybe add anything else to this program. Unless you guys can think of something. So the big major complications were just adding this additional variable here just to control the sensitivity. Now, if we make that value smaller, that means it won't turn as fast, right? But that might be a good thing. So for instance, right now, with this KT being 0.3, that's kind of capping it out at about 50 is about as fast as it's ever going to go there. But if we wanted to track faster, we could increase that KT value. So like if it was having trouble following something that was moving faster, we could increase that so it would go faster. In fact, if we increase that to like say 0.6, let's see what kind of effect that has on the pro. You know what? Now that I'm actually using this, that means that I can actually pair through the controller for once. And that will make things a lot faster. So so the brain, so the controller should get picked up, I think. Yeah. So you see how it turned green, the controller and the brain. So now I can just download through the controller. Oh, and that saves me so much more time and hooking up the cord every time. Okay, so now let's run it this time. Oh, okay. So it's definitely zippier, right? But it's still, you still have that kind of fine control when it's kind of closer, but definitely when it doesn't see it. I personally think the 0.3 is more my speed though. So I want to put it back to that. So by controlling that KT value, that's going to determine how sensitive our turn is. Let's take this one step further now. Okay, so that's pretty much all I wanted. I mean, that's how simple the vision sensor is. You notice we didn't necessarily write a lot of code to make it do that. All we did was we took a snapshot. Well, we wrote a function that takes a snapshot and then figures out a turn speed based off of the center X value of the object that we were looking for. And then, oh yes.
Can I show you my screen? Because I have some errors.
Sure. So you can share your screens now. So yeah, go ahead and share with us.
Can you see it?
Yes, I do. So let's, okay, so I can see a few things. First off, you didn't you don't have that configuration, so you can't say Vision 8 disk. You could try changing that So first off, is that what your vision sensor is called in your? Could you go to your devices? That's the little thing that looks like a phone cable. Okay, so you do have something called Vision 8, but you don't have yours configured because you don't have one to configure. So you can't actually use disk because you didn't make a thing called disk. However, you can replace that disk with like red in all caps, and I think that will just set up to track red objects. So you can close devices. And on line 65, you see where it says disk? Just change the disk part to red. In all caps. Okay, now your second error on line 66 is that center X, the X has to be capitalized. And then I think that will actually clear up the error in 71 as well. Because, oh, wait, in 71, you have to have an open. So you see how you have that closed, you have to have an open one too. Yep. Yeah, and wait, delete one of the closed because it created both of them. Yeah, like that. Okay, so it didn't try
I
deleting.
had to add a second line, lowercase line, because it was too short. But when I add another one, maybe that made it worse.
Okay, try deleting everything out of there. Yeah, everything. Like the whole thing. Yeah. Stop. Okay. Try start with a capital V. And see if it throws up an auto. Well, try continue to type vision. It's not giving you anything. I guess because we don't have any snapshot data. Let me. There is a way to use the default stuff. Hold on. Let me vision. Let's see. I'm trying to think. I'm trying to remember what the setup is for the. It doesn't really say in the help part. So try typing Vision 8. So and actually, let's not type Vision 8 at all. Just try red in all caps. Let's see if that works. Try hitting build now. Okay, so what to do? Let me think. It's so so I'm not sure how to call on those default colors. There is a way to do it though, but I don't remember what does any of you like Dennis or Logan want to take a stab at that? What the default is for those?
I mean, it's the good news is that the code's right. It's just that she doesn't have a sensor to actually take to declare those things, right?
Yeah. Yeah, the code is as you have it is fine. It's just you don't have it configured. Now, one thing we could probably do real quick, this would probably be the easiest thing to do. I'm going to post a line of code in chat.
If you wanted that standard built-in color, I typed one way to do it, I think.
Okay, what's that?
It's in the chat. It's Vex 2:, color 2:, red. Well, since we're already using the Vex namespace, I guess you would just do color, and then red.
In all caps or
I think it works with lowercase, but again, we don't have the sensor, so we'll never know.
okay, so just like that. So try typing what Brian said and see if that compiles. Is it Vex color red or I mean, so do you see what Brian typed in the chat? Guess I can try it too.
I'm about to pull it up.
His had 2 colons between each word.
Yeah. So Vex double colon color double colon red. Does that come? Does that build? No, that didn't build for me. Vex.
I don't. We don't need the Vex because we're already using the Vex namespace. So just maybe color : red.
Okay, color : red. Did that compile?
Say that again, I'm sorry.
Yeah, does that compile like what you have there? Yeah, that worked.
Yeah.
Brian saved the day. Thank you, Brian.
Awesome.
Okay, and it does have some default colors like red, blue, yellow. So it's just color, double color, and red. Okay, so if you want to check a red object, let me see if that works on. I'm going to actually download that to this brain. Let's see if it will track this red gear with that, with just using that red.
Would you need, Eric, would you need to clear out all of the ones that you've already done?
No, because although they're there, we don't necessarily have to use them. After all, I mean, we created like 3 of them and only used that one.
Okay, I was just wondering if because they were there, it's gonna use them or something. I just point of clarity was all.
Yeah, I don't think it will. Let's see if this works. So I'm downloading and I'm going to run this now. So here we go. Hopefully this works. Well, I guess it doesn't see this gear as red. Let's see if it sees this red as red. Well, why did it stop? Oh, my brain went white. That's weird.
Uh-oh.
Yeah. Yeah. That's weird. That shouldn't have happened. Did I brick my brain somehow? Did it not like that?
Oh no.
Yeah, no, okay, it came back at least. Yeah, it doesn't like that color red. It did not see it. So I'm not sure. It may be that color red has like some very, very specific values. But at least it compiled. That's why I recommend if you're using a color sensor, go through the configuration tool and set up your signatures. Oh crap, my brain bricked again. It definitely does not like something about that program though, because when I ran it again, yeah, we also got that white screen, which is not good. So yeah, there's something about that color signature is not liking. Oh crap. Well, I think my battery's in this. At that time, I'm gonna grab a new battery. Let's try that one more time. Okay, so let me just make sure it's back to normal. Okay. Okay, it's back to normal. Okay. All right. So we didn't completely brick everything. So that's good. Okay, so let's do something else. So with our ultrasonic sensor and our distance sensor, remember how we were talking about how we could write something so we can maintain a certain distance away. Well, wouldn't it be kind of cool if we combine that with our turn speed, and that way it would maintain a distance away and track something too. So that way, if you had some sort of colored object, it would just follow it around. So that's what we're going to do next. So we can keep this code as it is. Maybe I would save this as just what we have. But then I would probably save it again.
Will you share your screen again?
Oh, yeah. I'm sorry. I will. Share screen. And we want to share entire screen. Sure. Okay, so it should be shared. Okay. So what we're going to do, we'll save what we have as camera, but then I'm going to call this tracking. So we're going to add some more code to this. I want to save it in slot 3 this time. So we can kind of keep what we have. So we can have this turn speed and this KT, but let's add another couple of things. Let's make a new variable for keeping up with our forward and backward speed. And let's maybe call it something like drive speed or something like that. So let's make a new float. And we're going to call this one drive speed. And we'll start it off at 0. And we'll probably want a K value for it as well. So maybe I'll call it KS. And I don't know what a good value for that is yet. We'll have to kind of think through it. I'll set it at half right now, but we'll probably use it later. So I guess I should once again get in the habit of commenting these things. This variable stores the drive speed. This variable controls the sensitivity of the forward. Okay. And just like how we had a variable for set turn, how about we make one for we can maybe call it set speed, maybe? Is that already a function already? There's a set velocity. So we can call something set speed and it won't mess us up. So let's make a new function and we'll call it set speed. And let's open it up, and we're going to put some code just like how we did a set turn. This time we're going to do kind of a set speed here. Are we good so far? I want to give you guys enough time to, I don't want to rush too far.
Still typing.
Okay. So, anyone want to take a stab at what we're going to do here?
So do you need to take a snapshot so that you can like keep it at that certain distance or whatever?
We only need to take snapshots with the vision sensor. That's the only sensor. And the snapshot, once again, it just it basically just tells you what color you're kind of tracking for. But
All right.
Yeah.
So with set speed, we have a distance sensor on the robot.
Yes, I put a distance sensor on there.
So can we do a similar sort of proportional control, but instead of using it to turn, we use it to speed up and slow down?
Sure. So we made that drive speed variable, right? So we can kind of set a drive speed as well. So so maybe we could type something like drive speed equals, so we just need to set this speed. So what do we want to base that speed off of? So if we look under sensing, so since we did set up a distance sensor, we have things like the object distance, for instance. So we could use that, right? And in fact, let's use that. So object distance, maybe in inches instead of millimeters, because we're in America and we're going to use inches. So what would be kind of a distance we might want to maintain? Like maybe 2 feet. A 2 feet distance might be good. Especially considering that actually I have this the distance sensor mounted at the very back of the robot. So it's going to be measuring from where the vision sensor is. I mean, the distance sensor is. So I think 2 feet would probably put it about a foot in front of the robot, right? So that probably wouldn't be a bad thing to do. So do you remember how we did like the center X minus 150? Well, we could do the same thing with our distance. We can do object distance minus, so in inches, how much is 2 feet in inches? Isn't it 24 inches? Yep. Thank you. Thank you. So if we think through this again, if it's 24 inches away, the speed's going to be 0 because 24 minus 24. If it's less than 24 inches away, then we're going to actually get a negative value for our speed, which will mean it'll drive backwards. And if it's greater than 24 inches away, then we're going to get a positive value for our speed, which means it should drive forwards. Now, just like before, we probably want to be able to control the sensitivity of that a bit. And so what we're going to do is we're going to put that in parentheses there. This whole, and then multiply that this time by our KS value. Oops. And so that will kind of control the sensitivity of that. Now, honestly, it would probably be a good practice, instead of hard coding in a 24 inches, it would probably be good practice to make that 24 like a variable. And that way, if we need to adjust it, instead of like trying to find that where it's hard coded at, we can just adjust that variable. So that's what I'm going to do. I'm going to make another variable. Well, guess we can also make it a float. And I'm going to call this maybe target. And I'm going to set it to 24. And then, and I hope that's something, yeah. So instead of minus 24, I'm going to say minus target. Let's see if this compiles. So far. Yeah, it compiled okay. Now we haven't actually used it yet. So let's kind of think through some of the values that we're going to get here. So, okay, so the minimum we will have is if it was 0 inches away, and that would be that would be like a negative 25, right? Or no, sorry, negative 24. So that's actually not super fast. We might actually, and then if it were say like let's say we're 4 feet away, that would be 24. That's not actually that's actually not fast at all. So we may actually want to instead of doing like a 0.5 for a KS, which is cutting it down in half, we may actually want to multiply it by 2, maybe. And then let's kind of think through those values again. So if it's so okay, so obviously if it's 2 feet away, 24 inches away, then it's going to be 0. If it's like say 0 inches away, then it's going to be 24 times or negative 24 times 2, so negative 48, which is a decent speed back. And if it was like say 4 feet away, that'd be 48 minus 24 is 24 times 2, that'd be like 48, so that'd be about 50. So greater than that, it's going to be going even faster, but that seems like that would be a good value for our Ks, our constant. So do you guys agree with that, or do you think we should change it to something else? Okay, well, I personally think it's good. So, okay, so how can we use this then? Any ideas?
What do you mean? Like,
okay, so we created this drive speed. And we're updating. So what do we need to do to our main code now to actually use it?
We got to call that function somewhere in main.
That's true. So how about after set turn, we can do a set speed. So we'll call on, so we're going to call that function to update our speed. Okay, so we've called on the function, we've got our speed, our drive speed. Now what do we do?
see if it works.
Okay, have we actually, even though we are getting the drive speed, are we doing anything with it though?
No, all we're doing right now with the motors is using the turn
Yeah.
speed to make them spin.
Yeah. So what can we do to also use that drive speed?
Create a spin for and do left and right motor by the drive speed.
So like
Yeah.
create another set of but this time a spin 4.
I think so.
We want it to go forwards and turn left and right.
Yeah. We
So,
wanted to do both things at the same time, right?
so we kind of need to add together maybe drive speed and turn speed.
Yeah, that's exactly right.
And
That's-
that way, drive speed will be a constant for both motors. So they'll both be going forwards and backwards. Well, probably not backwards, but they'll both have a constant like baseline forwards velocity. And then if you add turn speed to drive speed, they'll have like some offsets based on which way they need to turn left and right.
Okay. Yeah. So in fact, and we'll kind of we'll walk our way through that in our heads. But so we have turn speed here. Why don't we just do drive speed plus turn speed? And for this right motor, and then for this the right motor, we'll still do drive speed, but this time minus turn speed. And then also let's change that reverse back to forward. Because remember, a reverse with a positive turn speed is the same as a forward with a negative turn speed, right? So, and I spelled drive speed wrong. Shame on me. Where is my cursor? I still have it spelled wrong. That's the problem. I can't see where my cursor is.
It's probably easier to just type the whole thing again.
Yeah. 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 So let's see if that compiles. Okay, so let's think through this. To think if it's actually going to work or not. So let's and I like to do this with the kids too, is to maybe like think through the code and think what it's going to do. If it has certain values. So let's say our disk is immediately in front of it and it's 2 feet away. So it's 2 feet away, dead center. What's that going to do as far as like left motor and right motor? So that if it's exactly 2 feet in front of it, what's the drive speed going to be? So if it's 2 feet or 24 inches in front of it, what will be our value for drive speed in that case?
0.
Yeah. Okay, and if it's also dead center in relation to the camera, what's going to be our turn speed in that case?
0.
Also 0.
So these will add up to 0 then, right? And so we'll have a speed of 0 for the left motor. And then these will also add up. 0 minus 0 is still 0. And so we'll have 0 for the right motor. So it won't move, which is kind of what we want if the object is dead center and it's the distance away we want, right? Okay, so let's talk through, let's say it's 3 feet away, but it's still dead center. What's going to be our drive speed in this case if it's 3 feet away?
12.
Yeah, but we're also multiplying it by 2 because our KS.
So 24.
Yeah, so our drive speed will be 24. What's going to be our turn speed if it's still dead center? Yep, 0, right? So our drive speed will be, so our speed for our left motor will be 24 plus 0. And our right motor is going to be 24 minus 0. So that means they're both going to be traveling forward. So the robot will be traveling forward in that case towards the disc, which should be what we want, right? Because it's 3 feet away and we want it 2 feet away. So we do want it to approach the disc. Okay, so let's now walk through a situation. Let's say the disc is 2 feet away, but it's off to the right a bit. So let's say we had, instead of 150, we had like 100 as our center X. What will be the drive speed in that case? So it's still 24 inches away. So since it'll still be 24 inches away, that's still going to be 2 feet. So we'll still have a drive speed of 0, but now our turn speed is going to be different, right? Because our turn speed will be like 50 times 0.3, which is like something like less than 20. But so we'll have a slight turn there. And so in that case, our left motor is going to be like have a speed of positive, say 20. And our right motor is going to have a speed of negative 20. Yeah. And so that will cause a turn. And then finally, let's maybe consider a position where it's like, let's say it's 3 feet away again, but then it's still off to the side of it. So then we would have something like, so we would have something like 24 plus 20 for the left motor and 24 minus 20 for the right motor. So that's going to make it kind of move forward a bit, but also turning at the same time. So we should be able to combine all of that, and that should, assuming everything works. I'm not going to run this on the tape because I have a feeling that would be a recipe for disaster here. So I'm going to set it on the floor here. And I'm going to maybe not share my screen for my code right now. Let me go back and stop this share. And let's see if I can position this camera such a way that you can see the robot. Can you guys see that okay, kind of? Yeah. Okay, so I'm going to hopefully this will work. So let's run this. Oh, okay. Okay, so you see it's backing up as I get closer. Now let's pull it back. Okay, so it's coming towards it. I think, and now it's falling to the left. It's falling to the right. Well,
it gets excited every now and then.
yeah. I think one issue is the size of this disc and making sure that the laser can still see it. Because if it's too far away, then what's going to happen? It's going to try to run forward until it finds something with the laser, right? So if this were, so that's why, like when we did our robot parade, we use those color license plates, but we also use a big, thick metal, well, a big metal backing plate to make sure that the distance sensor had something that it would always see. But it seems like it's working pretty good. So going back, you can't even see it anymore. Let me see if I can maneuver it over. So here it comes. Come on, come on. Whoa, okay, let's back up then. Come on. Let's follow it around. Yep. Yep. So let's stop. Okay, so that's some pretty complex behavior there, though, right? Being able to track and follow something and follow it around. And that's done with just a few lines of code. I mean, we didn't write like hundreds of lines of code to pull that off. We just wrote maybe a dozen at most, I think. Maybe a little more than that. And I don't know. I feel like, you know, for a kid that's just taking like a class like this for their first time, like robotics class, being able to have the robot do something complicated like that, I think is pretty cool. At least I think back if I had a class like this back when I was in high school, I would have liked it a lot. And it kind of shows that you can pull off complex behavior by doing some pretty simple routines, right? So what do you guys think of all that?
Yeah, I think my kids would really like that program.
It seems awesome. I do have a question about my curly braces.
Sure. If you want to share your code again, we'll look at it. Let's see. Okay, so what you're missing is you need to have a closing curly brace for set turn. So like maybe on line 71, you could put a closing curly brace. Because you want to close off that function. Okay. Is that distant 10? Is that what you called your distance sensor?
I believe so. Yeah.
Let's maybe look in your motor setup or your device setup, the little yeah. So what would you have it called? You don't have one. Okay, that's why. So you need to add one. So add a device and pick out a distance sensor. Back up one more. Well, you could do a rangefinder if you wanted to. It would be kind of the same thing. So you could maybe pick A and B if you want to just plug it in the, yeah. Okay, so and you can kind of close that devices now. Now the only difference is, so instead of a distance 10, so do you see where on line 76 where it says distance 10 object distance? You'll just change that to rangefinder A object distance. Yeah, you can just pick that rangefinder A if you want. The other thing too, while we're at it, so we did actually make a variable called target to kind of keep up with our target distance. So instead of hard coding in that -24, let's change that to minus target. And that way, if we ever want to go back and change that target later, we can. So let's see if that will compile. So we still have, let's click on sensing. And is it range? It is range finder distance. Okay, so instead of saying object distance, just say distance with a lowercase d. Okay, and then try compiling again. Okay, so what's the problem with target? What is the problem with target? Oh, okay. So you need to have a open parentheses in front of rangefinder. Yeah. Now let's see if that will compile. Okay. And that fixed all your errors. Okay, so what we're going to do now is discuss the final project and what you guys are going to do for a final project. So what the final project should be is something that kind of encapsulates, you know, all the skills that we've learned so far. So, and it's going to kind of also depend on what you have available physically as well. So, so if we look under, let's see what we have here. So if we look in Unit 12, it's got some example, like 2 examples of a final project. I'm going to share my screen on this computer this time, because I'm using all kinds of computers.
Hey Eric, I haven't checked my Google account over the weekend, and I finally updated and it says I have free storage. So,
Oh, good. Well,
if anybody, I don't know if it was just like mine was a glitch or something. I don't know, but after I deleted everything, it took it a couple of days to, or a day or two to register that it was free. So,
all right. Yeah, I don't know. Okay, so here are okay, so here is a final project. I think this is the one that Vanessa wrote, and it's basically like a kind of an obstacle course kind of thing where, let's see, so you will build and code a robot to navigate through an obstacle course created by your teacher. The catch, you must create it without seeing the course. Once the course is revealed, you only have 1 class period to finalize your code and successfully complete the course. In order to accomplish this, you must build and code your robot so that it's capable of completing a number of tasks before that day. Possible robot behaviors to prepare: auto straightening, precise turning, obstacle detection, both using the bump sensor and ultrasonic sensor or the distant rangefinder. Use manipulator to interact with the environment. So additional rules: no physical contact with the robot once started. You may have as many attempts as time allows, but you'll only be allowed 1 class period to do so. And the robot that completes the course the fastest time will receive bonus points. Okay, so basically the idea behind this one is they're not going to write all the code from scratch. The idea is that they'll make a bunch of different functions that will do different things, like maybe like a function to do a right turn, or a function to drive a certain distance, or a function to pick up an object. And at least that will be kind of available to them. But then on the day of, like, an obstacle course will be set up where they have to kind of string together those functions together to pull it off. So it's not like so much that they're writing the whole thing on the day of. They'll usually have like a week or two to come up with doing the different parts that might be there. And it would probably be a good idea to actually kind of reveal like what you're going to have to do. Like for instance, does it need to pick up a can and put it somewhere or something like that, so that it can kind of work through those things. But then on the day of, like let's say maybe it's the task is to pick up something and place it in a box, but that something is actually around the corner of a wall or something like that. So so that they would already have a function written for picking up things. They would have a function written for like driving and turning. And then on the day of, so they wouldn't know what the configuration of anything looked like. And on the day of, they would have to kind of put it all together. So this is kind of what this was kind of what Vanessa kind of had for a final project. So the one I kind of wrote, this was the one I did last year. I believe so. Yeah. So this was the robot parade thing. And it was basically that the robots had to follow another robot, and we incorporated in the ultrasonic rangefinder and the vision sensor. And so I think it was like the classroom super kits came with these like big plates. And so each of the robots, I had them mount one of these big plates and then put a license plate in the center. Or you could just like use a colored piece of tape, like a red piece of tape or whatever color you want them to track. But so I'll just read through this then. So your class is tasked with building, and I can make this bigger. You probably guys can't see it very well. Let's make that bigger. Can you guys see that better now? So your class is tasked with building robots for a robot parade for the elementary school. Your robot will need to be able to automatically track and follow the robot in front of it while maintaining a specific distance apart. The robot should use at least one extra motor to perform some sort of repetitive motion, such as waving at the crowd or juggling balls. Your robot should also be decorated to make it stand out from the other robots. So basically kind of making a parade with the robots. So the robot must have this 20 by, that's not 5 hole. Well, okay, so originally it was a 20 by 5 wide plate, but we ended up using these instead because we had them. But it had to be mounted on the rear of the robot vertically. This will serve as a reflector for the ultrasonic and distance sensor. And then it had to have the red license plate on the back, tracking so that the other robots could track it with the vision sensor. And then since we were using the color red, that means you should avoid using any red for any of your decorations of the robot, so as not to confuse the vision sensor. That's an important one because you don't want to you don't want to have all sorts of other things that are of that color because it's definitely going to confuse the vision sensor. The robot should use a front-mounted vision sensor and a distance sensor to track and follow the robot in front of it. The robot should maintain a distance of 2 feet apart from the robot in front of it. For instance, if the robot were to back up, your robot should also back up to maintain that 2-foot distance. Your robot should be programmed to stay centered with the red license plate in front of it. If the robot loses track of the red license plate, it should stop until it sees it again. So that's another thing that was different from the code we have. We actually want it to stop if it doesn't see something, because that way the robot in front of it can maybe back up or something to help it find it again. But the last thing you want if you have a whole line of robots is for them all to start spinning in place, because that's just going to throw everything off. the vision sensor should be calibrated to be very sensitive to the red plate, because the lighting conditions are going to change as we go through the halls. Your robot should include some sort of other eye-catching mechanism, such as waving an arm or a conveyor belt that moves back and forth. So, do something parade-like, not just being a robot. The lead robot, just so they know what the lead robot's like, it will have a 1-to-1 gear ratio and traveling at roughly 50% power. And it will make relatively shallow turns, because if it's too steep a turn, for one, if it's too steep a turn, then the license plate won't be in front of it anymore. And so the turns we made were really kind of shallow. And so that was our final project from last year. I think I could have swore there was another. I remember making another project that involved finding colored cubes and picking them up and dumping them in different locations based on the color, but I don't see that project anymore, which is kind of a shame. Before we move on, I do want to show off one other kind of cool thing with the vision sensor, because I didn't get to show this off yet. Here, I'm gonna change the camera here. I'm gonna turn off screen sharing for a second. Okay, so can you see the brain okay? Okay. So if you go into I think the settings of the brain, so you can turn on the vision sensor Wi-Fi, and then so basically that means the vision sensor is sending out a Wi-Fi address that you can connect to. So I'm going to use my phone and connect to that Wi-Fi. And so on here, I see a Wi-Fi thing called Vision 2F48, and I'm going to connect to that. Yep. So now I'm connected to it. Of course, it doesn't have internet, but now I'm going to open up a browser, and I'm going to type in 192.168.1.1, which is kind of like your home address.
So wait, where did you get those numbers from, or does it display that somewhere?
It doesn't. Okay, so yeah, it doesn't display those numbers. So how those of you who are kind of familiar with HTTP and stuff, how do you explain that home address? So I'm sorry. So 192.168.1.1, like say, for instance, like if you had a router at home, well, which you probably do, if you were to type in that would connect you directly to the router. And so like, for instance, if the router had like, say, a configuration webpage or something like that, so that you can configure your router, so basically that 192.168.1.1 is like the home address for whatever you're connected to. I think that's the best explanation of that. Now, in this case, I'm connected directly to the vision sensor. So the vision sensor is kind of acting like the router, except for it's not going to the internet or anything. So when I
was gonna say that number is just like it's like the true name for the the device. So it's like it's not something that everybody knows, and that's like kind of like a secret way to connect with it without having to, you know.
Well, yeah. So
Right. I get that. I was just wondering, like, how do I know? Like, so it's not going to be the same for everybody's vision
no,
sensor,
it's
huh?
it's always
It
going to
is
be
the same?
192.168.1.1.
It's just whatever Vex's Wi-Fi.
That's for it. I think pretty much everything, right? Not just Vex stuff, but
Brian posted in the chat the link.
Yeah, so the instructions for connecting tell you enter that number, and it's the same every time you do it.
so okay. So you guys looked up the instructions for that? Yeah. Oh, great.
So if you're at a competition or something with a lot of, or even in your class period where there's a lot of vision sensors, it's always the same.
No, well,
IP address?
the vision sensor actually has a unique name to it. So it's like
Okay.
and some letters and numbers. So each one, each individual vision sensor has its own thing. So like when you're looking at it, when you're trying to connect to someone in Wi-Fi.
Got it. Okay.
So at any rate, if you're doing it through a phone, you also need to make sure you turn off mobile data, because you don't want to be so that way when you go in your browser, it's not trying to connect out to the internet. Instead, so you want to just have the Wi-Fi turned on, and you want to have mobile data turned off, and then you open up your web browser and you just type in 192.168.1.1. And then what you get is, so here's my phone. And it is actually, so there, I'm sorry, I'm upside down here. So you can see whatever the camera sees, which is kind of cool. So I think I don't know if I mentioned this to you guys, but like 1 year, I did a project with the kids for their final project where we're kind of treating it like they were trying to store nuclear waste. And so that you wanted a robot to do that, and you wanted it to be able to pick up like a colored we were using like colored solo cups, but they were like representing barrels of nuclear waste. And they were supposed to pick up that solo cup and then deposit it in a storage container. And then what we did was they could either do it automatically using autonomous code, so doing the tracking and everything, or they could drive the robot manually, but they could only see through the camera. So like the course and everything was hidden from the kids, and they could only kind of view through their phone to control the robot and drive it around. Because the idea was it was a dangerous place. There was radiation, so people couldn't be there. So you had to send in the robot remotely. And so I kind of did that as an alternative for the kids that weren't great at the autonomous programming, so that they at least could kind of pull it off by remotely driving it. But that's another thing you can kind of do with the robot. So that's just another neat trick that you can do with the vision sensor, is you can actually view through its camera with any, and it doesn't have to be a phone you connect it to. It can be anything that has Wi-Fi and can connect to something. The only problem is if you're trying to do it through your school stuff, it will probably be blocked, because schools are not going to allow you to go to 192.168.1.1 because they don't want you on their service. So my kids couldn't do it through their Chromebooks because the school was blocking that site. But that's
even when we were on the vision sensor Wi-Fi.
Say that one more time.
No, never mind. It was just an IT question.
Oh yeah. Well, just because the Chromebooks themselves, I guess they had blocks set up. So because even if they were, even when the kids take them home and connecting to their home network, they're still not allowed.
Yeah.
They're not allowed to go everywhere. Because that would open up a whole new can of worms there. So, and yeah, and that being able to go to that home site is definitely something that's blocked because there's a lot of ways you can exploit that. So, okay, so what I want us to kind of do is think of a final project that you can accomplish with the equipment that you have currently. What's something that you could probably do to show off the skills that you've learned in this class so far with what you have available? So like, for instance, some of you don't have, you know, all the sensors and stuff like that, so you can't really use that. But it could be something like, say, driving towards an object and picking it up with your arm and putting it somewhere. And you wouldn't necessarily have to do that based off of you wouldn't have to do that based off of any sensors per se, but you could just like drive forward a certain amount, pick up something and take it somewhere and dump it. Or so that would be one possibility. Or if you have some sensors, you could probably do something a little more complicated. But we want to be able to, and I think Vanessa's probably going to pop on Tuesday to see your stuff. So we do want to kind of show off to her that you guys have done some cool stuff. So what do you guys have any ideas of what you'd like to try to pull off for a final project? So we want to make it, we don't want it so complicated it's going to take you a long time to do, because you really only have like the rest of today and tomorrow to do it. But we don't want it to be like super easy either. Anyone got any ideas for what they'd like to do?
I think, well, I finally did put the claw in there, but never tried it. But I think I might want to grab something with the claw. I do have the bumper sensor, so I don't know if I might need to extend it further out to where it touches something. What other sensor did I use, or did we have? Think. Maybe have it do a spin at the end or something like that. Almost like if I got through the obstacle course, it'll spin saying, yay, wow. But I mean, I'm looking at that bumper sensor right now, and definitely I think I can handle putting the claw in, even though I was, you know, late in getting it attached. Another sensor of mine, what other sensors did we use? Because I still have a box of them here, and I just don't have the vision one.
Okay. Well, we have the rangefinder. That's the ultrasonic sensor.
Okay.
That's the one that looks like two little speakers on it.
Okay.
In fact, I have one right here.
See about that, so I'm gonna write that down.
So you say you have a whole box full of sensors?
Yes, I do. I'll call them out. I have, well, of course, the bumper sensor. Let's see. I found the optical shaft, and it's empty. The shaft encoder. Yeah.
Yeah. You probably won't need to use that because the motors have. So that's one of the older sensors, and that was back before the motors actually had encoders built into them. So
Okay.
if you wanted to track how much the shaft was spinning, you had to put one of those encoders on it. But now the motors have them built in, so you probably don't need to worry about that one.
I found a potentiometer. I found a light sensor. Wait, light sensor. Okay.
Yeah, that gives you like kind of brightness values. So
okay.
so that's kind of one of those older sensors too. Yeah, so it sounds like you have a lot of the older ones that aren't really used that much anymore, but that doesn't mean they can't be used, because like you can still add those. Most of those are going to be under that 3-wire thing.
Okay.
So
And then
I'll go ahead.
I found a line tracker, and I found this funny little submarine thing. I'm trying to find the name. It's like a flashlight. Let me see if I can,
It might actually be a flashlight because there used to be.
It looks like, let me see.
Yeah, that is literally a flashlight.
Oh, okay.
So it's not necessarily a sensor. Yeah. So that's definitely an old discontinued product as well. So you can use that flashlight by doing a digital out and basically you can just kind of set the digital out to high or low, and it will turn it on and off.
These are the ones I found.
Yeah. Most of those are going to be your older sensors, but you can still find them in VEX code. Like for instance, I'll share my screen again for 1 second. So if we look under here under devices, and then go to 3-wire devices, so like that line tracker they have here, I'll just add one in. That light sensor you were talking about is here. I'll add one of those in. That potentiometer is here, depending on what kind you use. And so by adding those devices, it does. Now, if we look under sensing, it will kind of show us so like for instance, that line tracker, it has so basically that light tracker, it kind of works by, like, say if you had like a white floor and you put like a black piece of tape down. Usually you use the line tracker in sets of 3, which is why they're kind of skinny. And then basically, so if it's a black surface, it's not going to reflect as much light as a white surface. And so by getting the line tracker reflectivity, it's going to range from 0 to 100. So it's like a lower value would mean it's looking at a dark surface, and a higher value means it's looking at a white surface or a lighter surface. And so what you can do is what that means is like when the light tracker is directly over that black line, then you're going to get maybe a value of like less, probably obviously it'd be less than 50, but maybe even lower than that. So what you can do is you can write some code. So if the line tracker is less than 50, okay, so you would have like maybe 3 of them. And if the middle one is less than 50, then you know that you're on the line and you can go straight. Otherwise, if like maybe the right one is less than 50, that means that you're kind of off track a bit and you can turn back towards the line. Or if the right one is showing less than 50, then you can turn the other way to stay on the line. And that's kind of typically how you would use the line tracker. So it was kind of a cool thing back in the day.
Scott, I'm sorry.
So some of the other things you have, like that the light sensor, it kind of just like a line tracker in a way. It picks up a brightness on it. So like for instance, you could shine a flashlight on it to start something up, or it can detect when it's in a dark room or not. So versus being in a bright room. And so it kind of works the same way. You can get a brightness value. It's going to be from 0 to 100%. So and it just depends on how much light's shining on that light sensor. And then like your potentiometer, it's basically if you put an axle through that potentiometer and you can turn that axle, and the potentiometer will kind of track how much you're turning it. So you can kind of get, so you can get an angle in either degrees or percent. So the old potentiometers will go from 0 to 250 degrees. And actually, if you overturn them, you will break them. Well, they do have a new potentiometer, and it will go from 0 to 330. And I think the newer ones are also continuous rotation. So even if you overturn it, you're not going to break it, which is good. But it'll just kind of reset back to 0 again. So those are kind of the old sensors you have, and you can try to incorporate them into the project. You probably won't use them in the class unless you specifically decide to do some content with them. But Beverly, you might want to just stick with something like using the button in the arm just to kind of keep it kind of simple.
Okay.
Or the ultrasonic sensor in my arm. But you could do something like if you had like a full soda can or something, you could have the robot maybe drive forward until the button is pressed, and maybe that would be it hitting the soda can hitting that button, and then it would stop and then close the claw.
Okay.
And then maybe raise the arm and then back up or something like that. So that could be, so basically it could drive forward till it hits the object, and then the claw could close on it, and the arm could lift up, and then maybe could drive back with the object.
Okay.
So that would probably be pretty good if you could pull all that off.
Okay. I'll do my best.
Does that sound like something you might be able to do?
I believe so. I will definitely do my best. I believe so.
Okay. What
So-
about you, Leah?
Well, I have a question. So I have the vision sensor, but the app is still blocked. I sent the thing to my IT department, but I can't like get the app. So I
So-
can't set
Yeah.
up the vision sensor, correct? So maybe better, and I don't have a button sensor, but I have a rangefinder.
Okay.
So yeah, I don't know. So that's where I was like, well,
Do you? So one thing that could be done is I could just pull that line of code out of this. Okay, let me share my screen again.
right. And I mean, when we changed it where it didn't have the remember we tried to change it so it didn't have the so it said like code red, but then it like bricked your brain. I don't want to
Okay, so is this the code we're using? This is a totally different code. Oh, I'm sorry. Let me stop this share. I'm on the wrong screen. I'm on the whole wrong computer. So this was the code we used. That was some GPS sensor code you were looking at. Meeting disconnected. Okay, we're connected. Okay. Can you okay. So okay, so this so when you do all this setup stuff, basically what it's doing is just automatically generating some code that's hidden. And so we have this code that generates the signatures here. So basically you could just take this line of code and put it in your program to give you that signature. So like, for instance, if I were to just, so like that R strip would be just fine for detecting a red object, pretty much. So yeah, so you should be able to pick up pretty much any red object by using this line right here, this line 36. So if I were to like say, take this line of code and put it in chat. Give me chat. This Chromebook is not super fast, so if you
be able to.
Yeah, so try copying that line of code out of chat.
Okay.
And you wouldn't necessarily have to put it in with the rest. You should be able to just kind of put it in. Let me turn off my screen share again. Do you have were you writing the code we were doing just then? Okay.
Mm-hmm.
So could you maybe share your screen?
Sure. Should I use the vision one or should I use the tracker? Because I did both.
Either one.
I'll do it on the tracker one. Let's see.
Okay, so if you'll copy that line of code that I pasted in chat, we should be able to put it pretty much anywhere. Like we could probably put it on line 64. Let's try sticking it on line 64. Okay. And now let's go down to our vision largest okay, the snapshot, the line 73. So instead of saying vision 8 disk, let's say vision 8 R strip. And I think it's actually, yeah, it's actually you might want to just copy it from line 64 so you get it right. But I think it's actually got 2 underscores. Yep. So let's see if that will build. Okay, give us an error. What error did it? Oh, you just need to put a semicolon on the end of that line. Okay, well, let's try building again. Okay. So that should at least allow you to see red objects, at least under my lighting conditions, which I might be a little brighter than what you have in your room.
Right. But I'll try it and we'll see what it does. Well, I got to mount the sensor or whatever, but that's what I was working on. But yeah, okay. I'll see if I can do something with that and maybe I have the rangefinder, not the
Yeah.
That's not the one you use.
Not the distance sensor, but the rangefinder. But you saw what we did with Beverly's, right? How
with the rangefinder?
Yeah. How we just did rangefinder instead of distance.
You just switch it out.
Yeah. And I think the only difference was instead of saying like object distance, we just said distance because I think the rangefinder. Yeah. but that was really about the only difference, and it still worked the same way.
Okay.
So what are you thinking you might do?
Well, I mean, I guess I could. I don't know. I thought about trying to. Well, I really want to make sure I can finish this arm and make sure it actually works. Kind of the same. And so, but that would make it follow. I don't know. So I don't know. I was gonna say, well, maybe I could go like have it go pick it up, but that's not really going to use the rangefinder or the vision sensor necessarily.
So what if you? Okay, so you could mount. I mean, you could mount the vision sensor like above the arm, or like at the end of.
What?
At,
I have an idea.
okay.
Like, what if you had the vision sensor when it detects like a certain color, like red, the arm goes down and like attempts to grab, it'll go down, close, and then pick back up.
Mm-hmm.
It doesn't
Okay.
have to actually grab anything, but like when it detects it, it can do a function like to grab the red object or something.
Okay.
Yeah, that's a good idea.
Okay. I'm gonna do that. Or try.
This weekend, my nephews, they're 4 or 5 or 5 and 4, and they saw the little robot, and they made me let them drive it around. And I was trying to get my arm working, but I have the XP motors, and
It's just not strong enough.
well, no, they can move the arm just fine. I couldn't get them to program when the V5 software. I was trying to do it, but I couldn't figure out how to do the 3-pin, and then also call it in the code.
Oh yeah.
I think you have to put another library inside the code, right?
But yeah. So those. Yeah. So you have like some of the older motors.
Yeah, I'll show you. I'll show you.
Yeah, I see it right now with the green cap on the motor. Yeah. Yeah, that's
Yeah,
like.
But I have regular Vex motors. I just don't have any of the extra cables to connect them. But I'm gonna go to my classroom probably today and get a vision sensor and probably a couple other sensors too to try and be able to maybe add more to it or something.
Okay. Yeah. Yeah. That those old one. Yeah, that's the one thing I don't know if they have it in.
I Googled it and looked up. I was trying to research because every time I added them to the device options, and then I try to call their name, it would give me an error saying undefined variable issues. And I just think that there might be another library, because if you go to
what about where it says servo? I mean, can't
see, I was looking through that one. There's servo and there's motor 393.
Yeah, it should be a motor 393.
Yeah, that's what it is. And I did it, and it just every time it called that variable, it just gave me an error. And when I plug it into the brain, as soon as I plug it in, the motors activate, even without any code or anything. They just start running. So I don't know why that happened, but that was kind of weird. But it's just I'm not going to be using that anyways in my classroom because we have plenty of regular motors. So I'll just I'll get some cables at school. I'll program it right.
Okay.
I just got to take them off the bolts and bolt the correct one on there. It ain't really that big of a deal. So
yeah, that won't be too bad. One thing I do want to point out: those older motors, they had a different type. That they used to use like different screws for the motor screws. They're like
the little small black screws.
Yeah, the little small brass screws for the motors. Yeah.
Yeah, these are the ones that we're talking about. There's your lighting, but this piece, it's all steel frame, so it's pretty solid, except for some of the pieces or whatever. But yeah, they do use a couple different screws.
Yeah, the old motors used to use these old brass motor screws that were like smaller, and you had to use a smaller Allen wrench to get them. And they probably or a hex head too. The heads on those screws.
Yeah, they're not the star. They're small, little, probably like a 3 and 30 seconds or whatever, like whatever the tiniest one is. But yeah, so I just gotta mount this claw onto my bot, and I'll change the motors out with the correct motors, so I can use them.
Yeah. Okay. So assuming you got those motors hooked up, what are you thinking you might do? Just
I would like to be able to actually to detect a Coke can or something and pick it up, like
yeah,
go drive up to it and pick it up.
yeah. And I think a Coke can is mostly red, so it should be able to. If you
Yeah,
set that signature, it should be able to find it just fine. So yeah, I would like to see that happen.
yeah. I'm gonna try it out. I try to mount the vision sensor and then get the claw on it, and I think I can get it.
Okay, that sounds good. What do you think you might do, DJ?
So that's what I've been kind of figuring out. Since I only have motors, I think I need to be able to just kind of mess with the smart motors and have it do something. I might try to have it play a piano, like pluck some keys with the motor or something like that. I was also thinking marking a football field, like roll for a yard line, then move the arm to be like it would spray a
Yeah.
hash line, move a little bit, move the arm down like it was going to spray, something like that.
It's funny you say that. The way our football field gets painted is using a robot.
Oh, really?
Yeah, they have a guy who comes out like 2 days before the game, whatever, and
Uh-huh.
he has like a little bot. It's I don't know, it's not very big, and it'll go and mark all our lines or paint all our lines on the field.
Cool. So I might, if I can't figure, I might try the piano first, and if I can't figure that out, I might just have it do that and not actually spray a can because I
Yeah.
don't want to get
You're
spray paint
gonna
on
put a
y'all's.
permanent marker. You might put a permanent marker inside your claw, have a white piece of paper or poster board.
Yeah, it doesn't even have
And-
to be a claw. You could just tape a marker. It doesn't have to be a permanent marker.
Yeah.
Sorry.
Expo.
So yeah, I might do something like that. I think I have in my classroom like some big rolls of parchment paper that it could actually do some marking. So
Yeah. So that would be something you could maybe do.
yeah, kind of
Especially if
limited by what sensors I have. So
yeah, especially if you have a way to like raise and lower the marker, with a motor. Maybe you can make it spell or draw out your initials or something.
yeah. So something like that. Something.
Yeah.
We'll figure out what can I actually achieve.
Yeah. Do you have an idea what you might try to do, Brian?
So yeah, I've got motors and a bumper switch, and I've got it all on a claw bot. So I'm guessing I'm gonna drive until it bumps into something and then lower the claw and pick something up. I don't know, something like that.
Okay. That sounds like a good thing too. Yeah. Yeah, so that sounds good. Like maybe like you said, start the claw in a raised position. So
Yeah, well, the way mine's configured, I have to because the bumper switch is obscured by the claw at the moment. So it'll drive with the claw up.
yeah,
Maybe do auto straightening. I'll bump into something, lower the claw, pick it up, and go back. I don't something like that.
kind of like what Beverly is planning to do. Yeah, yeah, I think that would be a good for our final project. Okay, so now that we all have an idea of what we're going to do for our final project, I guess this is where we're going to kind of go into our asynchronous time. So basically, you'll have the rest of the day and tomorrow too, to work on this, and so like especially like tomorrow, if you're having, so I would at least try to get started today, and that way, if you're running into issues with the code, I can kind of help you with that tomorrow, or if you're running into issues, and then and so Wednesday is going to be pretty much a short day. What we're going to do is just do the post test and the post surveys, and I guess show off our final project. And that will probably be it for Wednesday. So, and then tomorrow is pretty much just working on our final project. How's that sound to everybody? So can you believe it? We're almost, it's been, you know, it seems like it's been a very short time that we've been together, and it's wrapping up. So.
Yeah, it's been eye-opening. You've been doing a good job, by the way.
Oh, thanks. Yeah. Okay, so so that being said, if you guys just want to hop over to asynchronous now, I can keep the line open if you have anything you want to talk about. But otherwise, I think that'll be it. So remember, our work today was vision, if you haven't done that already. I'm also going to, in the Google Classroom, I'm going to put up an assignment for the final project. And it's just like when you're done with, just submit your code there when you're done.
Hey, Eric, I got a question for you. So we're trying to configure our STEM room, and I see your backdrop with all your metal hanging up. Does that work out really well for y'all?
Yes. I really do like having the pegboards up like that.
Yeah.
That's really helped.
So-
Between having the pegboards and then having these bins.
Yeah, that organizer over there.
Yeah.
I like that too. I might try and I mean, I'm and this is something that I'm gonna try because Mike did this before. He kind of went up to like Home Depot and just told them like, you know, is there anything that y'all can donate to, like, you know, as like a something to contribute, that maybe not financial money, but like tools and stuff. So I'm gonna make like a wish list and then go up there, and that's some of the things that I want to get. I want to get a pegboard. That organizer I really like. And then Brian's leaving. So
Yeah.
and then that's and then some tools. Like I want some I want to get like not impact drills, but I want those little handheld really small electric drills just to make things a little easier. And I do need some like 1/4-inch ratchets. Do y'all use that at all? Like ratchets at all? Or is just
Yeah, we do. We do occasionally, especially if you're in a spot that's kind of hard to get to otherwise.
we have like it's not the Vex Allen wrenches because the stuff they give you kind of sucks, but so a lot of my kids are still using the little wrenches that come with it, which are terrible. So I'm just gonna get some stuff, like some simple things. But one thing that I was recommended to do and that I'm going to do is like kind of do like a training requirement on using certain tools like a Dremel drill and all that stuff, that where they're certified, that they've been told how to do it. So, you know, some requirements on that.
Yeah, that's a really good idea. Anytime you're, especially with power tools of any sort. So yeah, that could be something covered like that first week as kind of like a safety thing.
Yeah. And a lot of the kids that I have been in the same group since 6th grade, and they're going to be, most of them are sophomores. So, and I only lost one kid this year. So she graduated. She's in college now, but so my group's basically the same group I had before. So I don't know how to do a lot of recruiting. So it's kind of nice, but I do open it for anybody to join pretty much. So that's all I had a question about. So I'm gonna try and get that set up you got in the background, because we have a bunch of shelves we just got. So I might try to get some of that set up too. So.
Yep. Sounds good.
All right. Well, I'll see you tomorrow. You have a good day.
Yep. Anyone else have anything to need, or?
Yeah, I have a question. I'm gonna just be brave about asking. I noticed when we use the int main, with the int main, is the int main normally used when you're dealing with another segment? So let's say, yes, I'm doing the claw, I'm doing the button, because those are two different entities. Should I have an int main for one and then start up on another int main?
You're always only going to have one int main. Now you can write, so yeah, there's only going to be one int main, and that's actually telling the robot what to do. So anything you put in int main is actually the stuff that the robot's going to do. So if you have in the code that we wrote earlier, we also made some other functions And then we called on them later in int main.
Right, I noticed that. I was looking at, and for some reason, int main has stuck out with me for years, but I never, attached it to anything.
Yeah.
But I see what you're saying now, because at the top, there's a lot of info that's up there also with the statements in green, but then at the bottom, there's no statements under the int main, just the action basically.
Yeah. So int main is where you're that's where you're telling the robot what you're doing. So that's why all your code's going to be in there, but you can write those other functions that we made, like for instance, we made those functions today about about making the turn speed and the drive speed. So we did those as functions, but then we ended up calling on them and using them in the int main.
Okay.
So if you're trying to, so you could write a function for, like, say, driving forward to the buttons hit, and then you could later call on that in the int main. Or if you don't want to write it as a function, you could just put all the code inside int main if you wanted to.
Okay.
So you wouldn't necessarily have to make a separate function to do things. You could just tell it to do everything inside the int main. It's just, it makes it a little cleaner and easier to read if you make separate functions for the things you're trying to do.
Okay.
Does that, I don't know if that helped answer anything.
Oh, I was just, when you said separate functions, it's just that when I do the separate functions, I have to make sure I have a statement to help separate it better.
Sure, yeah. Like for instance, let's say, okay, so this code, yeah, we won't look at this code because this is complicated. Yeah, so you see how it has, yeah, so this code right here has some different functions, but
Okay.
then in our int main, yeah, we won't look at this. This code's pretty complicated. So let's, for instance, say media changes. Let's say we wanted like a code to drive forward until a button, until the bumper is pressed, for instance. So we could, I'll just go ahead. To simplify this, I'm just going to use a drivetrain.
Okay.
Well, no, I'll do the motors. So have a left motor and right motor like we have been doing. So we'll reverse the left motor, add a right motor. And we're also going to add a bumper. Well, let's say we have it in port A. So we could put all our code in here, or we can make a whole new function and then call on it later in here. But no matter what, it's not going to do something unless you put it inside the int main somewhere. So unless you put it in between these curly braces, it's not going to do anything. Like you might be able to declare variables and make functions, but unless you're actually calling on those functions, it's not actually going to do anything to the robot. So the things that you want the robot to do have to be kind of put inside this int main.
Okay.
So let's say, so you can write some functions like maybe we want to write a function so to drive forward until the bumper's hit. So we can actually maybe call it a function, And let's maybe give it a name, drive until bumped or something. So you can call it whatever you want. That particular function probably wouldn't have any parameters to it. So, because it's just going to drive forward until it's bumped. So in order for this to work, so we basically want to kind of do a loop to go forward, and it's going to continue to go forward until the bumper is hit, and that's going to be what exits us out of the loop. So what we'll do is we'll do a while, but we don't want this while to repeat forever. Instead, what we're going to do is say while bumper A pressing is equal, and we have to do equal. So while it's false, then we're going to do some stuff. So what's this going to do is it's going to check to see if the bumper is being pressed. If it's not, then it's going to do the stuff inside. And then basically what we want to do is just make the motors spin. So we can have a left motor spin forward and a right motor spin forward. And so what's that going to do is, so while the bumper is not being pressed, while it's equal to false, it's just going to run the motor. So it's going to let them spin forward. And then let's say we want to kick out of the loop. Okay, so it's going to, so you see these curly braces, it's going to do everything in these curly braces while the loop's true.
Okay.
So after we're knocked out of the loop, then we want to just stop our motors. So we'll do a left motor stop and a right motor stop. So so that would be us driving forward until the bumper is pressed, and then it's going to stop it. However, we haven't actually used it in our main yet. So in our main, we could just say drive until bumped. And that's actually going to call on it and actually use it.
Okay, wait, ooh, let me see. Okay, so after I see where you had void drive until bump at the top. Okay, you had all the explanation underneath it. Now you just dropped the first sentence under in main, which you didn't have to put left motor, right motor again because you spelled it out up there.
Yeah, so this is where we're actually making this function that we're going to do all this stuff. And this is where we're calling on it to use it. And we could call it multiple times if we wanted to. So like we could do drive until bumped and then do it again. Or maybe we want to do drive until bumped and then back up a bit or something like that. So so we could do after the drive into bump, we can maybe do maybe we could back up. Or maybe we in your case, you might want to do drive until bumped and then lower your arm and close your claw to try to grab something, right?
Right.
So
already I'm able to visualize how I want to put it on the robot. I got that part.
so maybe we would make a new function. and we could call it something like, we could maybe call it grab or something like that. And this could be all our code for grabbing something. And then when it's time to use it, we would just say grab, and that would use this
Wow, okay.
code. And then maybe we'd have another code for backing up a certain distance. So void, maybe we just call it back up.
Okay.
And so we could put all our code for backing up there, and then we could say back up.
Mm.
So
Void means just filling a void.
what void means is it's not returning anything.
Okay.
It's not, because a lot of times when you make a function, it's expecting a value to come back. So like, for instance, when you use any of these sensing functions, it's actually returning a value to it. But when you say void, that means that it's not sending any data back. It's just doing the thing, but not, say, returning anything.
Okay. Gotcha.
So if you were to do like a grab, well, first off, you would probably need an arm motor. So you would maybe add in another motor. In fact, you might need two motors. You might need an arm motor and like a claw motor, maybe.
Wow, okay.
Because especially if you're using those claws, it probably has a motor on the claw too. So you can have a motor for the arm and a motor for the claw. So
Okay. Okay, that's already hooked up. Yeah.
So what would a grab look like? It would look like something like, for instance, probably what you would want to do is lower your arm, because we're going to assume that it's up already. So you could do something like using the spin 4 command on your arm motor. And I'm not sure if forward is going to lower it or raise it, but it's probably going to raise it. So we probably want to do reverse. And then for however many degrees you think you need to lower it down. So that would be something you kind of work with if it doesn't lower enough. So another thing you're going to want to do is you're going to want to set your stopping type. So your arm motor, you want to set your stopping type to hold. And what that does is it tells the arm to try to hold its position. So wherever that motor is it's going to try to hold that spot. And you probably want to do that to your claw motor too. So so you probably want to set it to hold.
Okay.
So that's gonna be so that when you say raise your arm later, it's going to try to stay upright and it's not going to try to fall back down again. That's what that's doing. It's setting it so that it's going to hold its position.
Okay.
So, okay, so in this case, we've lowered our arm. That's what this line has done. And then after we lowered our arm, we probably want to close our claw. So so that will also be running the motor. So but this time it's going to be the claw motor. And once again, I don't know how much it's going to take to close it. So, but it will probably be in reverse to close it. And once again, these numbers you'll probably have to play with. Like, so if it doesn't lower enough, then this will need to be bigger. If if it lowers too much, then you'll need to make these numbers smaller.
Okay.
But this line right here, we'll make a comment. This lowers the arm. This right here would close the claw. And then we probably want to do another then we'd probably want to do another arm motor, and we'll go in the forward direction to raise the arm. And that could be our grab function. So when we run this grab function, it's going to lower the arm, close the claw, and raise the arm. And hopefully that will grab onto whatever you have in front of it.
Okay.
And then for your backup function, it could be something as simple as just going backwards for a certain amount of time, certain distance. So we could do our left motor and our right motor spin. But since we're going backwards, we're going to want to go in reverse. And I don't know how far we want to go back, but I'm sure it's going to be more than that. Maybe 200 degrees. I don't know how far that will take you. And then in this case, we want both these motors to run at the same time. So we will put a false here. And that will have both these run at the same time. And that could be your backup function. And so when this is run, basically what's going to happen is in our amp main, it sees drive until bump. So it's going to go up here and it's going to do this code, the drive until bump code.
Wow.
And then once it's done with that, then it's going to do this grab code. So it's going to do all this stuff.
Okay.
And then when it's done with that, it's going to do the backup code, which is going to be this code.
Neat. Okay. I see it. Wow.
So,
Okay.
so that's basically, that would be basically what you're trying to accomplish, I think.
Okay.
I kind of, maybe I shouldn't have provided an entire solution here.
Look, I'm hoping, but I know I'm gonna be challenged some kind of way, plugging in the degrees, the numbers.
Yeah, that's true, because you will need to work with these numbers to get that right.
I know something. I don't want to predict it, but yeah. It's gonna be something, especially with the numbers. And I did have fun the other day plugging in and plugging the robot back in and stuff like that. So I think that was a good muscle memory for me right there.
Good.
Okay. Thank you. And I'll be in touch
Okay.
if need be.
And Leah's hopped on the line, so I guess you probably have a question.
Oh yeah, I just have one question real quick. So these little bitty Metal Gear things.
Hold on, let me
You know
stop
what I'm
my
talking
gears. Yeah, those pinion gears? Yeah.
Yeah. So it's not going to catch on the axle unless I put one of those things in it, correct?
Yeah, you can't put those inserts in. There's let me show
Yeah.
you.
I have the green inserts too.
Yeah, that won't work either. Because Give me 1 second. Okay, so here's can you see this? Oh, okay. So that's what you have. There's this.
That
Yeah, and
that's got to go in there.
yeah that's
Got it.
right in.
Aha. Okay, that makes
So,
more sense.
yeah, that just slides right in. So it's like it's a metal kind of squared
It
off.
looks like a standoff, but it's square.
Yeah, square, and it's got a square hole inside it, and it's kind of
Got it.
beveled off, so the edges are rounded off. And that's what
Okay,
fits.
yeah, it told me to put one of those on the other one, and then this one it didn't say, and I was like, this isn't gonna work. And now I'm like, okay, that makes sense.
Yeah.
Okay, cool. Yeah, no, I got you. All right, I'm gonna keep trying to hopefully make this thing work. But perfect. I
Okay.
can do that. All right.
Hello. About to be. I'm going to